My name is Alan. I'm a volunteer docent here at the Computer History Museum. I'm glad you could join us today. And what I'm going to do is tell you the story of this machine, how it came to be, what it does, and its amazing inventor, Charles Babbage, how he went through life trying to build these things and never got them done. And Mike over here, he's the power supply of this machine. And you can see it is a hand-cranked machine. And Mike is very specially trained on how to do that. As you can probably imagine, there are many, many parts moving in this machine, which you'll see in just a second. And the timing, wow, okay, here comes the tour. One more minute.
The tour's just finished. We've just been on a tour.
Yes, they've been on a tour. Come on in, folks. So anyways, I was saying Mike is very carefully trained on how to operate the machine because as he turns the crank, the force on the crank changes very dramatically, but he cannot change from a very smooth operation. Otherwise, parts tend to jam or break, which we don't want to happen. So he's also very, very skilled in knowing about this machine, and we have questions he and I can both answer. So first, before I do anything, you guys have been staring at this for a few minutes as a beautiful sort of mechanical sculpture. And now let's watch it as a moving sculpture. And believe me, I'll answer a lot of questions as I describe how it works. But I think you want to admire how it looks and how it sounds when it's working. And Mike's going to crank through about 10 calculations on the machine. And if you've seen a few up front, you might want to just circulate clockwise around the machine to see what's going on in the back during this. You have about a minute and a half or so. So let's go ahead and do 10.
Wow. You want to walk around?
It's a very soft clack. You hear it, Mike? It's a very soft.
I wonder why.
Yeah.
5 of the 10.
Okay, if you haven't seen the back, let's go around the log.
Come over behind it. That's awesome.
All right, come on back around front. So let me first talk a little about Mr. Babbage and why he felt these machines were needed. He was born in London, England in 1791, and he was trained in mathematics. That was his main field, and he was really quite what you'd call today a sort of Da Vinci man. He dabbled in many areas of science, engineering, and math, although math was his principal subject. Obviously, he was a great mechanical designer as well. For example, he was really bright. During his lifetime, for example, he held a chairmanship at Cambridge University in England, which is called the Lucasian Chair of Mathematics. Now, this chair was held before him by a guy named Sir Isaac Newton,
Oh my
and more
gosh.
recently by a guy named Stephen Hawking. So I'm just giving you the caliber of that job. And he, during his lifetime, invented not only these machines, but he sketched up submarines. He built his own RV. He designed one of the first ophthalmoscopes to look in the eyes of your eyes, the doctor looking in your eyes. He even designed the cow catcher, the thing that used in front of locomotives to push the cattle off the tracks of a train. So, and he had an accident recorder, if you will, a black box for trains, keeping track of their mileage and speed and so on. So really, really bright guy. And he had one little problem, however. Like a lot of the real geniuses right here in Silicon Valley and around the country, he had a little problem communicating with other carbon-based life forms. I guess you might call it a geeky personality, but maybe some of you have had this experience. You go to somebody you haven't met before, you start a conversation, and in about a minute, you know you're going to have an argument. Right? Everybody met a person like that, I'm sure. And Babbage was that kind of guy, and it really got in his way during his lifetime of accomplishing things. I mean, diplomacy and negotiation were not in his vocabulary. And he didn't withhold his criticism of just other mathematicians. For example, here's a letter. I'm going to read you a letter he actually wrote to a guy named Alfred Tennyson. Now, very famous poet, right? Contemporary of his. And he didn't like one of his poems, so he asked him to please fix it. Here it is. Sir, in your otherwise beautiful poem, The Vision of Sin, there's a verse which reads, "Every moment dies a man, every moment one is born. It must be manifest that if this were true, the population of the world would be at a standstill. I would suggest that in the next edition of your poem, you have it read, every moment dies a man, every moment 1 1/16 is born." The actual figure's so long I can't get it into line, but I think 1 1/16 is good enough for poetry. Can you imagine Tennyson opening up this letter? So this got him in trouble many times during his life, and I'll talk about that a little more. But it does show that he had this amazing requirement for precision in his life. Precision, precision, precision. Get it?
It's like
right.
Sheldon.
Okay. In about the 1820s, England and America are embarking on what we call today the Industrial Revolution, right? We're starting to build railroads. We're starting to build bigger buildings and bridges, and all kinds of engineering work is going on. And Babbage and a colleague are reviewing books of mathematical tables. Now, for those of you too young to remember the days before computers, when I went to school, we had to solve a lot of equations and problems with mathematical tables and slide rules, and maybe electromechanical calculators, right, on our desks. And for example, here is tables of common logarithms. These are used to help you multiply and divide without going through a lot of fancy multiplication, so by just using addition and subtraction. And when Babbage and his colleagues started looking at these various publishers' versions of this book, what do you think they found?
Errors.
Yeah, there were differences between one book and the other, which should be the same number. Now, this is perfectly normal because to err is human. And they were calculating, while they were calculating these numbers with a very easy theory called finite differences, which I'll show you how that works in a minute, they still had to write down the answer. Who among us has not transposed a phone number or an address? They have to write down thousands of numbers. Then they leave these pages, these sheets, to a printer. And how did we print back in the 19th century? Movable type? Movable type, right. Can you imagine a printer setting thousands of numbers in a table like this and not getting one of them wrong? So there was lots of room for error. So Babbage said, I got to figure out how to do this perfectly, without error. And he embarked on the design of a machine we call a difference engine. And it's called a difference engine because the basic premise of how you get those tables is, let's say you come up with what we call a polynomial equation, an algebraic expression for whatever function you're trying to copy, to calculate. And then you try to solve that equation for every value of its unknown. And you generate a table. I'm going to go over here and show you how that works on the blackboard. I hope nobody's afraid of a little algebra. Okay? I'm going to show you with a very simple polynomial. The polynomial result or answer equals x squared, or x times x, plus 1, right? In order to solve this equation without doing a lot of squaring and stuff, we have to solve the equation manually one more time than this exponent. If it was a third order equation, I'd have to solve it 4 times. We only have to do it 3 times here. So let's do that together. When x equals 0, the answer is?
0.
1. When x equals 1, 2. And when it's 2, 5. That's right. So, now, I have these first 3 answers. I subtract the first from the second, and I put it in what I call difference column 1. Subtract the third from the second, difference column 1. I now subtract these 2 from one from the other, and put it in difference column 2, and I get a constant. If I'd had third order equation, I'd have to have 3 difference columns. Now, if I had a machine that just added these numbers together, I don't have to do any more squaring. The answer for x equals 3 is obtained by taking 2 plus 3 equals 5, 5 plus 5, 10. Answer for x equals 4. 2 and 5 is 7. 7 and 10 is 17. So the machine can just, if you can build an adding machine that does that, you can calculate the values of your equation. Any questions on that? So the idea was, Babbage said, if I can just build a very unique kind of adding machine that does this, I would be able to calculate any function that I can model with an algebraic equation. Okay. And by the way, the machine today is set up, in fact, to calculate common logarithms, these tables. And the equation to do that is not exactly as simple as the one on the board. It looks like this. It is a 7th order polynomial equation. It takes this entire page to write because the constant coefficients in front of the x's are very, very tiny little multi-place numbers. Okay, so Babbage says to himself, I'm going to build a machine to do this, and do it perfectly. So he sketches out a machine, which today we call his difference engine number 1, versus this one is difference engine number 2. So, once he has the machine, he builds a little bit of a model to show that it's probably going to work. And then he says, okay, I'm ready. What does any inventor need once he knows what he wants to do? Money. So, he goes, hey! So anyway, there weren't any venture capitalists in England in the 1830s, but of course the government's always good for a pound or two.
Grant.
So he goes to the Crown says, oh, good idea, let's try it. And then he goes and finds a fantastic machinist who can really build amazing stuff. And why do you need that? Because in the 1830s, believe me folks, there were no machines to make precision gears or any of these parts. So he found such a guy, and they began. Now, given Babbage's personality, they just went on and on and on. And after 10 years of working on Difference Engine 1, they only had 1/3 of the 25,000 parts that machine needed built.
Wow.
All right? And the government just ran out of patience, and he was constantly arguing with this machinist, who was also a bit of a prima donna, by the way. And they broke up. And in fact, the Prime Minister called him in personally to tell him they could have bought about 20 locomotives with the money they'd also already given him, and that was a bigger need. So he was heartbroken and very disappointed. You know, a real inventor that thinks his invention is going to change the world, pretty upset when he can't build it. So, but Babbage had moved on in his brain while the guy was building parts, and Babbage was visiting him occasionally, Babbage was trying to design a full-up mechanical computer. Now, how do I separate this evaluator of polynomials from a computer? Well, he actually designed a machine called the analytical engine, and it has memory, a processor, it is programmed with punch cards, and it has a printer. It's an amazing machine. He kept designing it through his whole life. In fact, he never finished it. Now, if people try to build that, they'll just have to figure out when to stop designing it. But he worked on that for quite a while. And then, in the end of the 1840s, he says, you know, now that I've done all this work, I think I can build a simpler difference engine. And he designed difference engine number 2, just as you see it, presented the drawings to the Crown. They said, no thanks, Charlie, we've moved on. And those drawings wind up in the collection of the London Science Museum. Okay? Charles Babbage, during his lifetime, never saw these machines built. Zero. Fast forward now. 1984-5 period. 1984-5. The curator of technology at the London Science Museum, his name is Doran Swade. He's a Babbage fan. And he and a guy from Australia conjure up the idea that let's build difference engine number 2 and see if it really would have worked. And they embark on a very similar odyssey to Babbage's, that is, need money, need machinists, need engineers, and so on. And they start. And by 1991, they hope to be finished. That's Babbage's 200th birthday year. But at that time, they only had the calculating section put together. That's from where Mike is standing to over here. And what do we got in this calculating section to show you? Remember, we have to do adding. I showed you on the board. Well, first of all, you have 8 columns of number wheels. There are 31 number wheels on each stack. If you're a computer person, you can call them registers. It's a convenient term. In between each number stack, wheel stack, is a set of gears. As Mike turns the crank, first of all, we calculate the initial differences just like the first row I did over there. We're able to actually make the wheels loose and turn them to those initial differences and lock it up and then start cranking. And as Mike turns the crank, these gears here will take this number stack, rotate it back to 0. So if it's at 4, it'll go 3, 2, 1, 0. All the time it's adding 1, 2, 3, 4 to the wheel on its left. Addition, right? Then this column disengages from the one it just added to put this one back where it belongs, because you just set it to 0. And so on through the process. So we add all the way across the machine until we get an answer on this column right here. Okay? Now, that seemed to work fine. The museum said, now what do we do? There's a very important part of this machine that has to be built. This is the printer stereotype. Remember, Babbage wanted no mistakes, perfection. What happens here is, on its next stage, the result is transferred over via these gears and all. There's a bunch of type wheels, number wheels in here. They're rotated to the answer. Ink is smeared on the type. The paper is brought up, and we print a check tape. Now, you won't see it you'll see the thing move, but we don't put ink in this every day. It's just too messy. Then, this tray down here, it's this bronze tray, it would be filled with like plaster of Paris. And other type is pressed down into the plaster to make an image of the answer. It then lifts up, the tray indexes in one slot, we go to the next one, answer, answer, until this tray is filled with impressions of results. What do we got when we're finished? We have a print master. We have a mold for a printing plate. The printer can pour lead into that, and no movable type. He gets perfect image, no mistakes. And in fact, all this gearing down at the end is variable formatting. You can change the spacing between the numbers, how many numbers you print, how many columns you print, etc. This is 130 years before Microsoft Word, at least. So, not only that, when the page is full, you need to stop, don't you? Because you got to change the tray. Well, there's a little cable running down over here which gets yanked on. And this cable pulls on this pole over here and turns off Mike's crank. So when the page is full, the machine informs him by shutting down. Babbage thought of all that. Well, the museum doesn't have money. What are they going to do? They're very fortunate that at about that time they get a visit from a guy named Bill Gates. And Bill Gates says, I have a chief technical officer, ex-chief technical officer, named Nathan Myhrvold. This is he. And he is a collector and entrepreneur, serial entrepreneur, and he would love this thing. And sure enough, Nathan subsequently contacts the museum and says to them, tell you what, I'll pay for you to finish that first unit. And if everything works, I want you to build me a second one for my own personal collection. And this machine behind me finished in 2008, flown across the pond in a 747, and he's letting us keep it here to show it to you, but eventually he swears he's going to take this thing home to Seattle and stick it in his living room. For that reason, Mrs. Myhrvold said, don't you guys use any stinking petroleum-based lubricants on this. So we have to use food machinery, silicones, and stuff like that. So we're taking very good care of this. It hasn't made a really mistake in years. So it really works. So that's the story of the machine. Now, yes, question?
Yeah, I know they didn't build it during his time, but what would they have used this for?
Who?
If they would have built it back in the
Well,
day.
for calculating tables.
That's it?
There was a specific problem that Babbage wanted to solve, getting those books of tables right, especially, for example, navigation tables. Remember, England was king of the seas back then, right? And you get lost if there's a bad number in your navigation table. So there was all kinds of calculations that could be done by the machine using this theory of finite differences. Question? All right. Now, we're going to crank it, and at the end, we're going to look up the answer and see if it's right. So you'll hear, watch the addition process go forward, watch it being transferred to the printer, and so on, and listen for the sound, you know the big clacking sound you may have heard when you first saw it work. There are big, huge blades starting at the bottom and running the entire length of all these columns. And those blades are specifically one, to realign all the gears in case they've slipped a little quarter of a tooth or half a tooth one way or the other, and also to keep them from moving when other things are happening in the machine. So you'll hear that clacking sound. In fact, that's why our nickname for Mike is that he's a clacker. Okay, clack away. Watch the print cycle come up here. Here we go. It's a print stereotype. The tray is going to move in. Print, stereotype. By the way, there are two stereotype trays because there's two fonts, one large, one small. I just got to ask, where is the other machine, the first machine? It is in the London Science Museum, but it is not regularly demonstrated. Now, at the top of the column, I can read off where on these log tables we are. You'll have to trust me on that. And it's 11205. So 11205 is right there. So take a look. I'll let you look at this. Can you hold your finger on that number? So the answer should be 0494119. Okay? So we have 0494119.
Yeah.
Wow.
Right on the machine. Right?
Yeah.
So there you go. All right. Now, very carefully, you have to pack in there a little. I want you to go around to the back of the machine. Be friendly. Watch out for the slanted column, it's all close.
All the gears and everything there.
Now, this is a very dramatic part of the machine. And what did Babbage have to figure out how to do? Well, if you guys add two numbers together, let's say you have two multi-digit numbers. You add the first column, and it comes up to more than 9. What do you have to do?
Carry bit.
You have to carry, right? Well, Babbage had to figure out how to do that. How do I carry? If one of these wheels goes from 9 back to 0, I need to push the wheel above it by 1 digit. That's carrying. So what he did was this. As the mic is cranking, there's a little complicated looking piece of mechanism called the carry lever. It's right under my finger. It's made of bronze. It's quite fragile. And you see it's got a very complicated shape. What happens is, as the number wheel goes from 9 to 0, it pushes on this mechanism and it pops out by 1 notch. Right now it's not multi-notches, but it pushes it out 1 notch and says when you get around to it, you have to carry. Because you know, you don't have to carry when you add numbers together, guys. You can add first, carry later. You get the same answer. So he does all his addition first, and then we carry later. So we get this carry warning. And then, at the right time, you want a picture of this? At the right time, these rods come around from the bottom, starting at the bottom, to the top, polling the register, if you're a computer person, looking for carries. And if one of these levers is extended, it's going to push on it, and it's going to push the number wheel above it 1 digit. And the reason they're staggered is when you push that number wheel 1 digit, it could be going from 9 to 0. So you have to carry that one up. So we do it from the bottom to the top. Questions on that? This is a very fragile part of the machine, by the way. When it was first delivered and it wasn't aligned properly, we broke a few of these. And the cranker wouldn't even feel it happening. But not now, we're in good shape. So, I want you to watch carefully. Now, some of the coefficients in this equation are big negative numbers, if you notice from the equation. Some of these constants are very big negative, very little negative numbers. As a result, in order to do negative numbers on this machine, we use 10's complement, right? Meaning, like, -1 is 999999999. Okay? So, there'll be a lot of carries going on in some of these columns, especially this one and this one over here. So as Mike turns the crank, watch carefully at these little levers and see what's happening. So let's do that. Okay, the reset, carry needed here, carry needed there, and carries right, zoom right up. Once again, right here, carry warning. Carry, 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 right up.
Wow.
Now to me, I have no idea how the guy thought this up. It's just absolutely incredible mechanical piece of gear. Any questions on the carry process? Okay, let's go around front and we'll finish up with you guys.
Yeah.
Okay, we need a new assistant here. Sir, step forward. We now, by the way, I'm reading that we're at the 1121. We're at 1121, right? So the answer is going to be 0492568, right?
Oh, I'm behind you, Dad.
4960566. What did I roll? What did I say? 0492568. 60566. Is that right?
Wrong.
Wrong. Wrong place. 1121. Yeah, it's 1121.
210.
11
210.
11210. 112.
210.
This one right here? No. 11210. That was
So it'd be 049605.
6056. In fact, 0496056. You can see it right here. Is the answer.
Wow.
And of course, it's accurate to about 27 decimal places. So, okay. Lastly, what's the place of Mr. Babbage in computer history? That's why we have a museum here. Well, there's lots of books written on Babbage, and he's honored as a forefather of computing, great mathematician. And when I read these books, my conclusion is that, of course, had he built the machines in his time, he might have advanced computer history by decades, even though it was mechanical. The whole concept, you know, if somebody comes out with a revolutionary invention, take an iPad, people all over the world copy it and repurpose it and advance it until some other revolution comes along. Well, but he didn't build it. So we honor him as a pioneer in that regard. And the one thing, though, that's interesting is that he had a protege that worked with him. She was the daughter of Lord Byron, the poet. Her name was Ada Countess of Lovelace. And her mother had her educated in mathematics. Quite unusual for the 19th century. And she loved Babbage's work, went to work as sort of a protege. And during her lifetime, she did a couple of amazing things. One, you could tell by the papers she wrote that she foresaw modern computing a little bit because she recognized that numbers that pop up on these machines could also represent characters in the alphabet or symbols and so on. She also wrote some of the first code because she had to prepare to program the analytical engine. So she did some preliminary work at computer programming. And most of all, a nice young female really helped Babbage get out of a lot of hot water, right? Given his personality. So she would intervene and maybe, you know, help get him through a crisis. So unfortunately, she died very young, but in the middle of the 20th century, she got a computer language named after her called Ada, A-D-A. And the story of Ada Lovelace and Charles Babbage is very interesting. It's on a DVD in our museum store. You might be interested in having that. It's a really, really good story. So that's about it. If you have any questions, Mike and I would be happy to answer them. We're going to do 5 more cranks here, so you can take your final pictures, and we'll be around to answer questions. Thank you very much. One thing, I will also be giving a tour of Revolution, our main exhibit, a 1-hour tour starting at 2 p.m. You'll meet me right outside the entrance to from the lobby entrance. See you then. Thank you.
When you talk about Ada writing programs, would it be this machine or would it
No, it was with the